thank you everybody for being here today. The webinar today is about data mesh, the new foundation for data-driven innovation. We will be focusing on life sciences, and this webinar is brought to you by Thoughtworks as well as Amazon Web Services. My name is Ammara Gafoor. I'm a principal technology consultant. I work for Thoughtworks, and today I have two of my favorite speakers with me, and we have Kowalski. So Ra, say hi. And Ra is a senior solutions architect who's joining us from AWS today. And my other co-speaker is Kiran Prakash. Kiran is a principal engineer also from Thoughtworks. And something that we're trying new for this time is that you may have noticed we have a little bit of a pin, which has, we'll have some scribbles and drawings going throughout this webinar. So we have an artist from Scriberia joining us today, and hopefully that'll make it an interesting and fun webinar. Yeah? All right, let's get. So for those of us who have been working in the life science industry, data is really, the fact that data is important for business outcomes is really nothing new. What is, however, different and what has really changed, what you can say, is the sheer scale at which the usage of data has changed, the very speed at which we are trying to use our AI models with our data. Whether it's in research and development, and it's about identifying the right in silico compounds that we could use for our experiments, or whether it is in manufacturing and having the ability to have a real-time inside view into your manufacturing facilities at every stage of your value chain. There's now suddenly this ability that we can actually have a competitive advantage. And that's exactly what companies and firms in this space are trying to do. Trailblazers are trying to set their competitive advantage. They are trying to identify how best they can use their data. Gilead, for example, has built a data platform and an AI and ML platform, and this has been built on the principles of data mesh and on the AWS infrastructure. And the whole idea of this is that they can scale up their AI and ML experimentation. Bayer, for example, is focusing on their preclinical data. For them here, this sets the competitive advantage in that space by allowing them to access their preclinical data across the value chain. For those of us who are aware of data mesh, we know how advanced the Roche implementation and what an industry standard the Roche data mesh implementation has been. They are focused on all aspects and all different domains to make their data scalable and interoperable. They really live this concept of their vision, faster to patients at half the cost. And they're trying to achieve this using their data. Just because there are opportunities and there are competitive advantages, that doesn't mean that we don't really need to address the underlying aspects of data that have always been a concern to us. From traditionally siloed value chains or the lack of interoperability, that is still something that needs to be addressed today. This, coupled with ever-evolving regulatory requirements and having the needing to face new frontiers of medicine, it's sometimes tougher than ever to actually not only scale, but also survive in such a competitive market. Thoughtworks and AWS, we address scalability with fit-for-purpose solutions. So whether you need intelligent products, or you need a data platform, or you need a data strategy, there are different aspects that help you solve your specific problems. In today's webinar, we'll be focusing on data mesh. And with that, I hope you learn how to use your data mesh for scalable solutions. Over to Kiran.
Thanks, Ammara. I'll start with a brief introduction to data mesh so that we are on the same page for rest of the talk. Let's start with the definition. Next slide. So data mesh is defined as a decentralized socio-technical approach to govern and share analytical data at scale. So what does it mean and why is it important for us? Next slide. So if you think back of how we as an industry have addressed the problem of data and analytics, right from the early 2000s when we started with like the data warehouses or the later iterations of data lakes and data lakes in cloud, they solved for various different scaling problems, right? So the data warehouses solved for the problem of how do I take a lot of these transactional data that I have, put it in and use it for analytics and business intelligence. How do I kind of create these views where I can roll up and down and do efficient filtering and such, right? And the data lake supported also like scale in terms of a variety of data. Now we were not only were able to crunch structured data in tables, but also unstructured data like images, JSON files, text files, and stuff, right? And then the data lakes on the cloud gave us the ability to kind of horizontally scale our compute as well as storage. But one thing that remained common was that all of these approaches had this problem of having a central kind of data platform or data team, which would take all of this data coming in from your transactional system, put it somewhere central, warehouse or lake, and then try to sort of provide insights to the rest of the organization, right? And the failure mode that we were seeing again and again was that this central data team or data platform team would often become a bottleneck in the organization. Like what Ammara just demonstrated, if you're in a life sciences firm, we see the applications of data and analytics throughout the value chain, right? So the requirement of, let's say, your R&D organization from the data and analytics would be very, very different to your to the requirements from your manufacturing organization or business unit. So what used to often happen was that there used to be kind of one central data platform team or data team who were expected to kind of have the same amount of domain knowledge or competence to solve analytical problem in all of these domains, which never would happen. And they often would get like conflicting priorities and messages from each of these departments. Like everybody needed the reports yesterday, not just today or tomorrow, right? And more often than not, these platform team, the central platform team, would become a bottleneck. And data mesh as an approach was tailor-made to tackle this problem of scaling scaling with the point of view of organization, with like a huge organization which has this various need for data and analytics. Next slide, please. And the data mesh kind of rests on these four core principles. The very first one being, instead of having one central data team, why can't we have multiple data teams that are aligned to this business domain, right? And they are kind of building these things called data product, which are solving the problems within their domain first, but also built in a way that it can be reused across the organization. The data product also kind of applies the product mindset to world of analytical data. It thinks about the users first. How do they want to use the data, right? Like, for example, your data engineer would want to consume the data using an API versus a data scientist who just want to connect their, let's say, Jupyter notebook to do some ad hoc analysis, versus like a manager who might want to consume the same data product using a report or a dashboard, right? So the data product is about thinking about the customer and putting their needs ahead of everything else, and taking that product mindset to data. And then the third pillar is these data product teams, which are domain aligned. They need some infrastructure services, right? They need storage, they need compute, they need a way of controlling their access, they need a way of monitoring what they're building in production, right? So the third pillar is about abstracting all of these capabilities into what we call the self-service platform and making it available for the product team, so that they can focus on solving business problem instead of the same engineering problems over and over again about how to store data at scale, how to compute data at scale, right? And the last pillar is what we call computational governance. And this is about, we want these autonomous data product teams to build data products, but in the end, we want them to be interoperable. Like, we want to create this network effect within the organization where you're building this reusable data product, which will be used again and again for multiple use cases, different combinations, of course. And the computational governance is about what kind of governance rules these teams agree upon, and how do we bake those rules into the platform so that the enforcement becomes easier and scalable. Because the old ways of like having a data steward and kind of manually monitoring whether we are following a certain practices won't scale with multiple with this federated teams approach, right? So that's really the crux of what the computational governance is, and taken together, these four principles kind of go hand in hand, and they reinforce each other to create this data mesh. Next slide, please. So this is just like kind of an artist rendition or an illustrated future state of how it would look, right? Like basically multiple domains owning their own data product, built using the common governance rules, using the self-service platform, the capabilities within the self-service platform, and built in a way that they are interoperable. And the interaction between the data product is creating these new use cases, which was not possible before. Next slide. With that, I'd like to hand over to Ra.
Yeah, thank you, Kiran. Good evening or good morning, wherever you are. So as we heard in the introduction, life sciences companies have to generate insights from the data, and they have to do that, across the entire value chain, from research and development to clinical, to manufacturing, to commercial, just simply to stay competitive and address the market challenges. And many new insights can be found only if you can do analytics across those different value chain domains, therefore unlocking the data from the traditional data silos. And, maybe it's a R&D data lake and manufacturing data lake and so forth. You need to really be able to do analytics across all of those different silos. To enable that, many customers have been trying to implement the so-called FAIR data principles. So FAIR stands for, findable, accessible, interoperable, and reusable. And why those FAIR data principles really originate from the research community and was published in a famous Nature paper, they can be applied to all data sets in the company. Unfortunately, achieving FAIR data principles in practice hasn't been easy due to many factors like organizational structures, people and processes, limitations, data quality issues, data platform silos I mentioned already. But we believe that data mesh is a good way to operationalize the FAIR data principles at scale. Therefore allowing the organizations to unlock the full potential of the data and to generate new insights. And even if you currently may be thinking, but I have this generative AI and AI strategy to elaborate, and how data mesh and FAIR data principles fit into that and help me implement my AI strategy, I have good news for you, because we believe that data mesh, and especially, implementing those, operationalizing those FAIR data principles will enable you to implement a wonderful and successful AI strategy, because you need this data products for fine-tuning your LLM models, or even building architectures which are, using the data from your data stores, called retrieval augmented generation architectures or RAG architectures. So you really need to have the data accessible and of good quality to profit, from the newest, if you like, Gen AI, wave. So now let's have a look at this table and just look at the mapping of the data product characteristics, which are defined for the data mesh, and was mentioned by Kiran were defined in the book by Zhamak, and how they map to the FAIR data principles. So the FAIR data principles in the column on the left, they are mapped to the data products characteristics, and we can find, for example, that the findable, FAIR data principle is supported by discoverable and addressable data product characteristic. So we can go further, and find out that the accessibility of the accessible FAIR data principle is supported by at least three different or four different data product characteristics. So not only they are addressable, those data products, but they are also self-describing, secure and natively accessible. And I don't want to go into detail. We will go into detail in the white paper we mentioned at the end of the webinar. But you can go, through the different FAIR, aspects of FAIR data principles and see how they map, to data mesh or data product characteristics, and see that there is an extremely good support from the data mesh principles or data product characteristics for the fair data principles. Next slide, please. Similarly, if you look at the data mesh principles in general, for example, the domain ownership, the data product, data is a product, the self-serve data platform, and the federated compute governance, we also find that they support a number of dimensions in the fair data principles. The data product is the king of the hill. I mean, it checks all of them. But also, if we look at the data platform, it allows really this fair data principles at scale, because not only I can do and discover, go there and discover and find the data progress I want to consume, but I also have the self-serve mechanism to access them. And the interoperability aspect, which is checked for data product, data platform, and the governance, federated governance, is really, how the data mesh is enforcing or somehow supporting, the common standards, policies, which enable those interoperability, a potentially reusability of data products. So you will find probably very interesting to ponder those dimensions yourself and try to kind of do this mental mapping between the fair data principles and data mesh principles and data product principles. And you are really invited to do so and read our white paper where we go a little bit deeper into this discussion. And now I will hand over to Ammara for taking us on a journey for real life examples of how our customers implement data meshes in HCLS space. Over to you, Ammara.
Thank you, Rana. Thank you so much. Now that we've understood and heard a little bit about what is data mesh and how it maps to fair data, terminology that we are very used to, it is with this understanding that we worked with a lot of life science companies and firms and different departments within these firms. And I think something that I like to often say is that if we don't, there are certain known set of problems. And if we don't want to change the way we approach them, then we can never really hope to have a change in the outcome. And I say that because often we have these 4 principles of data mesh, and we hear often, yes, data as a product is the king. We relate to that, and we would like to do data as a product. However, domain decentralization, this might be a little bit too much for us. Or federated computational governance, this is pushing in. What we would like here to say, or the point I'm trying to bring across, is that these 4 principles, yes, they exist and they all support each other. They're interlinked and they reinforce each other. 2 of these principles have a higher impact on the operating model and the organizational structure. When we talk about data as a product, and when we're talking about domain decentralization, this does have very, very tangible impacts on how you're actually working within your organization. It might mean introducing certain new roles like a data product owner. It might actually mean splitting an existing team into 2 so that you can have 1 data product team per domain so that they can actually not redo the same thing every time, but focus on the business outcomes. When we talk about self-service data infrastructure as a platform and federated computational governance, we're taking traditionally, especially when it comes to governance, we're taking something that is traditionally an operating model. It sits in governance teams and boards, and we are saying automated instead, we call it federated. That means along with having your governance teams and boards, make sure you're also implementing these checks within your data products and making it part of your architecture as well. And it is by actually implementing all 4 aspects and all 4 of these principles that you're actually going to make a step further into your data mesh journey and using your data at scale. When we are talking about operating model and organizational structure, like I mentioned, this may mean introducing new roles, but also upskilling new roles. Very common and a very tangible impact of this operating model change is actually moving from a project mindset to a product mindset. Now, this is key phrases that we hear very often, project to product, but what does that actually tangibly mean? It means, for example, if you would like to have a new dashboard or you would like to have data for a new LLM model or for your Gen AI use case, It doesn't mean that you have to go through a 2-year cycle of saying, I would like to request data. One domain requests data, it's put into a backlog. Another domain has to pick it up, and then they have to prioritize it. And then maybe in 6 months or up to a year, you might get the data, maybe in the format you need, maybe not. What we are asking is to bring this distance closer. And this requires aspects of change management. This requires aspects of coaching and training on how to think in the product mindset. And most importantly, it also requires top-down executive sponsorship. We are asking for that kind of support, and we are asking for that kind of foundational sponsorship to make this change happen. When we are talking about impact on technology and architecture, we're talking about the self-service platform, of course, and along with the self-service platform, we're talking about your federated teams that require now new tools to operate. For example, if you're asking teams to exist independently, data product teams per domain, then they also need to have the tools to actually do their job most effectively. We need to provide these services to them from the platform, which works like a product itself, and we need to ensure that there is consistency in the way we operate across our different domains, and we need to govern this with what we call as fitness functions. Now, when we made this talk today, we really discussed whether we want to go into detail of fitness functions, and we decided not to because it requires a little bit of depth of understanding, but thankfully we have written it down in our white paper. So I highly encourage you to actually read through this as well, because governing through fitness functions is really what sets the governance aspect of data mesh apart from the traditional governance approaches. So in conclusion here, tech and org change should go hand in hand. Treating it as a technology shift only, then the organization tends to fall back to old habits. And if we focus on only on the governance and the org changes, then the data product teams are not really getting the kind of support that they need in terms of infrastructure, in terms of architecture, in terms of guidelines, in terms of governance, in order to actually independently create these data products. And at that we have seen in our experience can really lead to a high total cost of operation, which is something you definitely don't want. And therefore, the tech and org changes have to go hand in hand. And we highly recommend a very robust, scalable, simple onboarding process to ensure that different business domains in your organization are actually able to go along the same path and are able to follow the same process. Again, detailed much more in our white paper. So I wanted to bring along some examples to make this clear. The data mesh implementation at Roche, which is a pharmaceutical company in Switzerland, and here we were focusing on the diagnostic as well as the pharmaceutical sections of Roche, really was one of those large-scale data mesh implementations. And they were very, very strongly worked on ensuring that there was scalability in their process. So they very strongly defined a process that each individual business domain had to go through in order to onboard the Roche data mesh. And in this process, they were able to scale their efforts to 20 plus business domains, which is no easy feat. And when we're talking about 20 plus business domains, we're talking about hundreds of use cases. And this is what allowed them to be pioneers in the industry. They did this by also tackling governance and by tackling technology. So they supported the platform, which supported these use cases. So they really built the platform up first. But at the same time, they had this group-wide program management that set up these processes, that scaled these processes, and set up this data governance that was then computationally enforced. So when I spoke about the process for data mesh, this is one of the processes that they defined. Every single business unit that had to onboard to the data mesh, the Roche data mesh, went through a different process of actually learning what is data mesh, understanding what are their high-value use cases, defining these use cases and identifying their data products, and then actually building their data products. What you can see here as well is that there's parallel execution of building these data products, identifying and building it, but also building the operating model and exercising the governance that goes hand in hand with the use cases, which is exactly the technology and operating model hand-in-hand approach that we recommend. A different approach taken by Gilead, for example, was to focus very much on the importance of developer experience. If you remember, we touched upon this, where we said that if you want teams to function independently with the support that they need as data product teams, then you need to provide them with the solutions and the services to allow them to function. They shouldn't be reinventing the solution every single time. And in this case, Gilead said, if we're going to have a lot of data product teams, then we should have great developer experience. No developer should need to learn a new language, or just because it's already existing like that in a different team. And so here Gilead basically set up their developer experience by ensuring they had a self-served environment for provisioning. They created templates for developer starter kits. They had integrated CI/CD pipelines, automated data management workflows, and observable data governance metrics. For them, this was the highest priority, which allowed their data product teams to be as efficient and as scalable as possible in their scale of work. The third example I've brought to you here today is about a global British pharmaceutical giant. And something that was really, really interesting to me is about how they approach their scalability, and that they realized it's not possible to change their entire operating model. It's not possible to just change the structure of the organization in order to be more scalable. Many of these companies are hundreds of years old and have structures in place with business as usual. So in this case, this global British pharmaceutical giant used data mesh and data products in their center of excellences. And they targeted these center of excellences as a place of innovation and as a place where data would be made available and would be consumed. One of their key metrics for doing this was to ensure that there would be at least one data product team per center of excellence. They would use these data products provided by the center of excellences, and each one of them would be able to be consumed by simple APIs. And these domain centralization aspects of the center of excellences would be identified using methodologies like event storming. Their measure of success here was, if we can increase the number of modeling experiments that happen per center of excellence, then we know we are actually making progress. And they realized by actually setting this up and modeling this as per the data mesh principles, they were able to achieve 70% of time reduction in the setup that is needed and in the number of modeling experiments that can be run in a specific duration of time. Irrespective of where you start your journey, and these examples were chosen for a particular reason, whether you can go large scale and you have, for example, this executive sponsorship that allows you to scale to multiple domains, or you would like to start with a technology first approach in the form of, say, a developer experience, or you're targeting your center of excellences. Every company has to identify what is the area of competitive advantage they would like to target, what is their as-is state today, and where can they go with. And therefore, data mesh is the solution that is able to address every need, and it just depends where is the starting point for you. So that was examples for us. You might still need to really look into what are some of these in practice key principles that we have learned while doing. And for that, I would like to hand over to Kiran, who can really walk us through that.
Thanks a lot, Ammara. So Kiran and I are going to talk about few key practices that we have seen really work in our previous sort of data mesh implementations at scale. I just want to preface it with saying that no, this is no way a comprehensive list, and you'll find the more kind of in-depth, detailed treatment of these practices in the white paper, which I, of course, encourage you all to download and read. With that, let's just dive in with the first key practice. So this is what we call the specification-driven developer experience. Next slide, Ammara. So we did speak about, when we are talking about the four principles, that we want the product team, data product teams, to focus on shipping business value while we abstract away a lot of the engineering concerns into the platform as a service. And we think this separation of concern is really, really important for scaling your data mesh and letting your kind of data product team focus on the right problems instead of kind of reinventing the wheel over and over again. And how we have seen it done in some of the big implementation is that we have this platform team which would focus on building capabilities. of the platform, various capabilities like storage, compute, observability, develop a sort of a portal and stuff like that, right? And they would expose these capabilities as using, let's say, a capability registry. And we have seen it done a couple of ways. It could be as simple as a pipeline templates that are available, or it could be via a platform API that is available for consumption from the product teams, right? So the key idea is that the platform team abstracts away a lot of these capability concerns and then makes it available to the product team on a self-service basis. And the product team is kind of merely assembling these, taking these capabilities and assembling a data product using a specification language. Next slide, Ammara. So which could look like this, right? On the left, you see it's a simple JSON specification. You have a name for a data product. It has a particular owner. It has a domain. It has input port, output port, all of the structural elements that is needed to create and operate the data product, right? So the product team just declares it, and then maybe they deploy it using their CI/CD pipeline, or they kind of submit this request to a platform API, which kind of provisions all of these necessary moving parts on the platform, right? You pretty much have a running scaffold, and the data product team just need to focus on what is the core transformation and what is the core representation of that data product that I need to make available for the consumer, right? They're really actually this kind of specification driven development and creating that separation of concern between the product and platform team really allows the data product team to focus on the right sort of problems, which is what problem do I need to solve for my customer? What is the insights that I need to create for them? What kind of ML models I need to develop and ship, right? So that's the first practice I want to reinforce, which is basically the separation of concern between platform and product, which is not actually given in all organizations. Next slide. And the second practice I want to talk about, which is closely related to what I spoke before, is having a consistent definition or meta model of what a data product is, right? We often see that data product has this strange problem that everybody understands those two words, right? Data and product. But the challenge is that everyone understands data product in their own way. It's kind of a blind man and the elephant kind of a situation where there are a bunch of people kind of feeling the elephant and kind of having a mental model of what that animal is, right? Somebody says it's a wall, somebody says it's I don't know, like it's a huge tail, whatever, rope and things like that, right? And this creates a problem in a way that whatever these autonomous team ends up building, if they're not compatible, you cannot connect them. You cannot interoperate each of these data product and create this newer use cases, which is one of the big promise of the mesh. How we tried to solve that is we really came up with the rules of what is the minimum requirement for something to be called a data product, right? It could look like this, right? That the list is like it needs to have a proper name, it needs to belong to a domain, it needs to have a proper owner. The team needs to think about the service level objectives and make that transparent. It needs to have like a proper output port like that it needs to expose and stuff like that. So once you come up with the rules, excuse me, you just don't leave it as a soft rule on a slide deck somewhere or on a Confluence page, because nobody's going to follow that rule, right? So what we did, next slide, Ammara, was to actually bake that rule into a data catalog, for example. So catalog is one of the key pieces of or key capability you would have in a data mesh self-service platform where people come to discover what data product exists, right? And that also becomes a point where you could start enforcing these validation rules, right? Because a lot of these data catalogs offer something called meta model. And you could really have a rich meta model for what data product is. You could have an asset of type data product, which can enforce a lot of these rules I was talking about, right? For example, this is one of the real meta model we created using Colibra. I think like that was a catalog which was used, but you could do it in Purview and various other modern catalogs these days. But the key idea is that you have the rules and then you bake that rules into your catalog, which is enforcing these validation. If somebody is trying to publish data product and it doesn't conform to the commonly agreed upon rules, like it doesn't have a product owner named or it doesn't have an SLO name, it won't allow you to publish something as a data product. So this is one way of kind of getting to that agreement about what that data product is. Next slide, Ammara. So the second piece of the same puzzle is once you made that server-side validation rules, you also kind of provide that capability to kind of register to catalog, also using the same specification I was talking about. So what we're trying to do here is a good example of what we call the computational governance, which is basically you're enforcing the rules using automation, like what I just said on the catalog, but you're providing tools for your data product teams to do the right thing. It's really easy to kind of do the right thing, and probably difficult to do something which is different to this governance rule, right? There's really no reason for people to not publish data product according to these rules, because you have like a ready SDK that they can use. They just need to declare the fields like what is the name, who is the owner, what SLOs, and then you have the server-side component, which is kind of enforcing these rules using validation, programmatic validation, right? So this is another example of what we did in order to create that common understanding of what a data product really is. Next slide. Another practice which we followed, which is also very similar, you might have gotten the drift by now, is one thing which is really important for data product is that it needs to be trustable, right? Because if you want others in the organization to consume your data product and build their solution on top of it, they better have the confidence that they're building it on a strong foundation, right? And one way to do that is surfacing what we call the reliability metrics also in the catalog, so that people can judge for themselves how good a data product is. We use the same technique, basically using the same specification. A data product team can register the data product to be observed, right? In the previous example, we used a platform like Monte Carlo, which was capable of basically measuring certain service level indicators directly on the data warehouse. The data product team would just declare it in the specification, saying that I'm interested in measuring the freshness of, I'm interested in measuring the completeness in terms of row count and the variation from the mean, right? And stuff like that. And then what our platform would do is that first it will configure those monitors so to be automatically measured, and then using the REST API, it will also publish those metrics into the catalog. Next slide, Ammara. So in the catalog, when people come to sort of discover your data product, they can already transparently see what is the availability of a data product, what is the completeness, and all of the other SLOs, and kind of judge for themselves whether they want to use it and build their solution on top of it, right? And we also kind of created this little thing called a key asset score, which gave them like an indication of how well a data product has been conforming to its promised SLOs over a period of time, over a kind of a rolling window of 20 days, right? So which means that it's not just like the measurement which was taken yesterday, but it also gives them a confidence that this team has been upholding their service level objectives for a period of time. Hence their sort of key asset score is high, right? So these are all the ways which can create that trust in your organization. That one key problem we see is that, yeah, like people see that nobody owns the data product. There is very little trust. They end up creating duplicates. They end up creating their own data product, or even in worst cases, they end up creating their own platform. And this is the thing that we are trying to kind of avoid by taking the product approach and really making those SLIs, service level indicators, really, really transparent. And to be able to do that, you kind of use the same developer experience to make it really easy for the product team to measure and publish service level objectives. Yeah. With that, I'll hand over to Ra, who's going to talk about another of such practice.
Thank you, Kiran. That was a really, impressive, run through three key practices. Let me focus on the fourth practice, which is related to how you actually go about building the self-service data platform. Next slide, please. With AWS, at least, we believe that we have an excellent, AWS cloud platform with the breadth and depth of services, which are really impressive, over 200 plus services. And we believe that this is a really excellent place to build data meshes or multimodal data meshes, as we see a lot of our customers build. Now the question is, how do you go about doing that? And a lot of wisdom and insights have been already shared by Ammara and Kiran. I would like to concentrate on the platform view. And so on this picture, we have 3 planes and 3 layers. And many customers, or when you start on embarking on the data mesh journey and build your data platform, you tend to focus on the data infrastructure plane only. So you kind of have this one layer view of the data platform. What we would encourage or suggest that you look at that at least in the 3 layers here depicted. So obviously you have the data infrastructure plane where you have the basic computational storage networking capabilities, low-level access control mechanism, security, maybe some tooling for CI/CD. But then the second layer or the data product experience plane is very important for your data product teams, the domain owners of the data products, how they go about and develop those products, how productive are they, and and this is very important, to be able to support this data product developer journey, right? So in this plan, we see what Kiran just described, how you can declaratively create a DP. So data product, defining those output input pods, ownership and so forth, how you secure those data products, what is the versioning support for that, maybe some metadata templating, or enforcing some standards, which also mentioned in Kiran's talk, and how you basically build, deploy, and monitor data products. And this is crucial to the success of the whole data mesh initiative, because the easier you make for teams to build those data products, and the more they are kind of, if you like, good and very productive developer journey, the bigger the adoption of the platform will be. And the last but not least, there's this third layer, or this third plane, which we call mesh experience plane. So how do you see basically this mesh, and large? So how you go and discover and explore, what data products are there? How do you manage the policies, security policies for them? Maybe some governance issues are managed, through this plane. How you can explore, for example, the emergent graph of data products, which data product is transforming data, consuming data from another one and producing something else. So all of this, including some governance elements of the data mesh, are in this plane. And let's dive into that. So next slide. Thank you. You're reading my mind, Ammar. So in the mesh, let's focus on the mesh experience planes. That's the last one we just, described. At AWS, we have, very exciting announcements. So there is a new service called, in the middle layer of this picture, you see basically this mesh experience plane as seen, through the lens of AWS services. And we are very happy that we are, expecting the general availability of a service called Amazon Data Zone. Amazon Data Zone is one of the services, very few services, AWS services, which will provide a out of AWS console experience for the users. And this will be called Data Zone Data Portal. Users will be able to log in there with, the federated, authentication, so their federated identities, provided by Okta or other, IDP providers. So they don't need to have necessarily a user or, a role in AWS account. Once there, they are basically able to discover data products which are registered in the business data catalog of Data Zone. And those products will be, having the metadata Kiran described, how you basically make sure that all the attributes which are belonging to a properly defined data products are there and reflected and can be searched or at least, discovered. Once the user found something, or many of the data products of interest, they will be able to consume them, and there will be a support for a kind of subscription workflow for those data products. And we call this functionality data projects, which are combining, if you like, the data product, people, and tools together. I have no time to go into detail how the data projects are a little bit, if you like, different from data products. They definitely, contain data products, but then they add additional elements to that. For example, what kind of tools could you use to consume those data products, and then can through so-called deep linking, they can be invoked directly in the Amazon Data Zone data portal. So that would be a support for the mesh experience for the first party data. Underlying the technical catalog and the access control mechanism are provided by a service called AWS Lake Formation. For the third-party data, so for example, imagine you have a data set which is available external to your company, and you want to, for example, consume data from a CRO, or you have some kind of real-world data coming from some external provider. We provide a service for that, and it's called AWS Data Exchange. And this is a marketplace for data products coming from external providers, where you can discover again and subscribe to those data products. As you see, this data mesh experience plane allows those different domains, like research and development and clinical and manufacturing and commercial, come to this place and discover and consume data products from different domains, and potentially unlock, the insights by combining the analytics and queries across domains. Next slide, please. That's a little bit of an overwhelming slide. I won't get into details about every single service, but let us say that because of the breadth of our services, we can cover the not only the mesh supervision plane or the mesh experience plane as we just described. So we have the data zone service there with the underlying lake formation, potentially also Glue, which is providing Glue catalog, and the before mentioned AWS Data Exchange services. But we also have a lot of services which can support you in the data product experience. So basically, data product developer journey. I want to emphasize that we have a lot of services, specifically custom or purpose-built services for life sciences under the umbrella of Amazon Health. So Amazon Health Lake is, for example, a FHIR service, which is providing you a service which enables for patient records to be served at scale, and analytics can be done on those records. Amazon Omics, which is now renamed to Amazon Health Omics, is a service which is allowing you to use this service to provide a data product around omics data, being it genomics, transcriptomics, or any other omics data, where you can package that, and query that through the service. And as Kiran described, you could provide an output port for querying a genomics data through this service. Very, very useful, and it basically alleviates you from the heavy lifting, heavy lifting of building such a omics store yourself. So any other, other services, I want to maybe emphasize also the Amazon SageMaker, which is ML, AI and ML service, which can be used, to really build models, train models on your other data coming from other data products, and then maybe the model itself is a data product you would like to publish again, to the mesh. So the endpoint, the inference endpoint of the model could be, your output port and the data product you provide. Last but not least, I would wrap up with saying that we have a really impressive or very large number of services in the data mesh infrastructure plane. We have over 600 plus EC2, so computing, elastic computing instance types available at Amazon. Our simple storage service S3, Amazon S3 is the object store you can use for all your data. Incredible scale and reliability of the service. We have, of course, networking services, and you can build your pipelines also in serverless manner, using also functions in the cloud, being AWS Lambdas or any other kind of, for example, step functions workflows. So with that, in addition, of course, security services, logging service, and so forth. I think we are closing, so I encourage you to, of course, have a look at the white paper, click on the links which are provided in the white paper to the individual services to discover more, and of course, talk to us if you need to understand better, what they can do for you. And with that, I turn over to Ammara, which will take us for the final key takeaways of this webinar, and maybe Q&A if we have time. Over to you, Ammara.
That was amazing. I feel like I learned about so many more services right now at AWS available, and especially that they are so specific also for life science and healthcare. So I'm actually super excited about that. So thank you everybody who joined us today. We hope it was valuable to you. We have 3 simple takeaways. If we would like for you to remember something from today's webinar, is that do remember that it's a decentralized approach, and it's about how to actually scale your analytical data, and therefore looking at it from both organizational and technical change lenses. Especially in life sciences, we find that this is more important than ever. Do not focus on the technical changes alone or the organizational changes alone, but look at a balance of both, and to ensure that you're actually able to leverage your data at scale. Like we've mentioned multiple times today already, we do have a white paper that's already published and that you will be able to access after this webinar as well, and you will be able to receive a link from us, or you can find it online, and it is already published. Again, if you have any questions, feel free to reach out to us. But I believe we have some time right now, so maybe we can take a look at a few questions as well. I believe we have something in the chat, or I see a couple of questions. So we have one question from David. For large organizations with established processes and entrenched incumbents, what is a thin slice strategy to implement a data mesh solution without too much interrupting or disrupting existing ways of operations? So I believe, Kiran, you would like to take a shot at this?
Yeah, I can take a shot. Maybe you can add later. So we see that, right? Like we see these processes like in large organization, they have like a set ways of doing things. But one of the things that we have encouraged while working with large organization in introducing data mesh is like having that sort of some written down process of how you onboard new use cases and domains. Like that's what Ammara was showing. If you want to scroll back, Ammara, like to that sort of double diamond process. And one of the key steps we do as part of this is what we call discovery. And the goal of this discovery is to find that thin slice, not just in terms of what is the use case that we are building, but also in terms of what is the thin slice of platform that we will be establishing, and what is the thin slice of the first organizational and governance changes that we would like to introduce, right? And we like to look at that thin slice holistically and come with a plan of, okay, what can be reasonably be implemented in, let's say, 4 to 5 months, because that's a time frame we think that a transformation program like this should start showing value. Otherwise, it kind of starts basically there is a risk that the management kind of loses hope in it, right? Like especially in times like this where everybody's kind of struggling to with cost cutting and whatnot, right? So we really encourage to using this discovery methodology, we kind of find that thin slice of the use case, the governance that we can change, and the platform, and then we try to kind of execute that in a short manner while gathering the feedback on and then adapting it to sort of next use case or the next domain, right? So that's pretty much how we have been done, and we also written about it. I think there is a blog post on martinfowler.com, which will talk at length about how we do this sort of workshops and what are some of the tools that we use to really define that first thin slice of value. Yeah, Ammara, do you want to add to it or?
Yeah, I think just you did cover all of it. I think just one thing that worked for us was when we started at Roche, especially, it was exactly this example. We started with one domain and we started with 2 use cases, right? We didn't start with 20 different domains. And the data products, and then the first use case that you build, it's really not any faster or any better or more scalable than any other use case that you have built anywhere else, right? Or with any other methodology. Where we really were able to show that scalability was when we did the second use case at an insanely faster speed than ever done before. And that really created that goodwill in the organization where they realized that reusability of the data product by 2 completely different teams that were able to use this data from the first one independently that were created and actually trust that data was what allowed us to get these what we call executive sponsors or goodwill sponsors within the organization who realized the business value of being able to use data that you trust. So it was a lot about word of mouth. It was a lot about starting small and scaling. And so if you're just starting, then it's thin slice across all different dimensions, but also prove your value and then scale. Another anti-pattern that we often observe is that we see a lot of clients spending a lot of time identifying the exact data products. Like, what are those exact data products that exist in the domain across all our use cases? So we see something called as pre-scouting. It's what it's often called. We will use our domain, business domain, and we will look at all the use cases potentially available in this domain, and then we'll find all the data products that can serve all these use cases. And that is something we do not recommend. We often see that if you start with fundamental 1 or 2 use cases that are important to your domain, then the fundamental data products generally tend to emerge anyway. So those are the core data products that will exist. So don't spend that much time in identifying your data products. Use a simple, iterative, scalable process. Get through 1 or 2 use cases, and you will see that data products will emerge by themselves. So yeah. Anything you want to add to that, or are we good?
No, it was music to my ears because we see, the same anti-patterns and similar approaches, like the analysis paralysis state, or we have to find those data products perfectly, or those, if you like, the initial set, and prove the value of the data mesh by finding those. I think we are really looking for this network effect, right? So the quicker you are able to bring data products to the data mesh as a living organism at some point will definitely bubble up those who are valuable, and the data products which are of quality, trustful, and so forth. So I wouldn't also recommend spending too much time in cracking and trying to crack what are the perfect initial set of data products. So that definitely resonates with us a lot. And I hope our listeners and attendees of this seminar or webinar rather had really a blast and could take some of those inputs, and of course enjoy reading the white paper and go and build, as we used to say in AWS.
Thank you very, very much, everybody, for being here. Special shout out to our friends from Scriberia. This is fantastic. And yeah.
Thank you. Yeah, it's I need this on my wall.
All right. Thank you, everyone. Have a wonderful
Thank you.
Thank
Have
you.
a nice evening. Bye-bye.
Thank you. Goodbye.
Bye.